Hello students, welcome to your science lesson. Today we are going to continue with Unit 6, Language of Chemistry. We are going to look at molecules of compounds and valency of elements. By the end of today's lesson, you will be able to demonstrate understanding of molecules of compounds, recognize the formulae of the molecules of some common compounds, demonstrate understanding of the valency of elements. Let us recall about atoms and molecules. What is an atom? What is a molecule? Try to recall the definition of atom and molecule. Yes, an atom is the smallest indivisible part of an element which can exist. A molecule consists of two or more atoms chemically joined together. From the previous lesson, you would recall that in metals, the atoms are arranged very close to each other. As you can see on the screen, in the metal aluminium, the aluminium atoms are arranged very close to each other. Noble gases like helium, argon, and neon exist as separate single atoms as shown on the screen. On the other hand, elements like oxygen and chlorine exist as molecules consisting of two atoms chemically joined together. Well, students, today we are going to learn about molecules of compounds. What is a compound? A compound is a substance which is made up of two or more elements chemically combined together. Some compounds and their constituent elements are shown on the screen. For example, water is a compound made up of the elements hydrogen and oxygen. Carbon dioxide is a compound made up of the elements carbon and oxygen. Methane is a compound made up of the elements carbon and hydrogen. Ammonia is a compound made up of the elements nitrogen and hydrogen. Nitrogen dioxide is a compound made up of the element nitrogen and oxygen. Some compounds like water, carbon dioxide, and methane exist as molecules. As you can observe, one water molecule consists of one atom of oxygen and two atoms of hydrogen joined together. One carbon dioxide molecule consists of one atom of carbon and two atoms of oxygen joined together. One methane molecule consists of one atom of carbon and four atoms of hydrogen joined together. Each of these compounds is made up of nonmetals only. Their molecules consist of atoms of the nonmetals chemically joined, combined together. Usually, when a compound is made up of two or more nonmetals, it exists as molecules. Water, carbon dioxide, and methane are compounds which exist as molecules. Molecules of compounds are also represented by formulae. Now, let us learn about the formula of a molecule of a compound. You have seen earlier that each water molecule is made up of two atoms of hydrogen and one atom of oxygen. The formula of water molecule is capital H with a subscript 2 followed by capital O. So, the formula of the compound gives the symbols of the elements present in the molecule. As you can see, you have the symbol of hydrogen and the symbol of oxygen. You can also see that the symbol of hydrogen H is followed by a subscript 2. This subscript indicates the number of hydrogen atoms in one water molecule. So it represents two atoms of hydrogen. You can also see that after the symbol O, there is no subscript. In fact, a subscript 1 is not written in a formula. Now, students, try to find out the formula of the molecules of the following compounds: carbon dioxide, methane, and ammonia. The formula of carbon dioxide is capital C, capital O with a subscript 2. This is because in one molecule of carbon dioxide there is one atom of carbon and two atoms of oxygen. The formula of methane is capital C, capital H with a subscript 4. This is because one methane molecule consists of one carbon atom and 4 hydrogen atoms. The formula of ammonia molecule is capital N, capital H with a subscript 3. This is because one molecule of ammonia consists of one nitrogen atom and 3 hydrogen atoms. As we have said earlier, a subscript 1 is not shown in a formula. The formula of a molecule gives the symbols of the elements present in the molecule as well as the number of atoms of each element in the form of subscripts. As we have seen earlier, the formula of carbon dioxide molecule is capital C, capital O with a subscript 2. The subscript 2 shows that there are 2 oxygen atoms in one molecule of carbon dioxide. However, a subscript 1 is not written after the symbol of carbon because a subscript 1 is not written in a formula. Let us now learn about the valency of elements. To start with, consider the 2 examples given on the screen. As you can see, in one carbon dioxide molecule, we have one atom of carbon combines with 2 atoms of oxygen. In the methane molecule, one atom of carbon combines with 4 atoms of hydrogen. So, children, how can you explain this? This is because of the valency of the different elements. In fact, each element has a valency which its atom uses to combine with atoms of other elements to form compounds. The valency of an element is its combining power. Let us now try to see what is the valency of an element. To help you understand the valency of an element, we are going to use an analogy. Consider 4 building blocks, each one having a specific number of hooks as shown on the screen. The pink block has 1 hook, the blue block has 2 hooks, the green block has 3 hooks, and the yellow block has 4 hooks. These blocks can be joined to each other by pairing their hooks. A correct structure is obtained when no hook remains unpaired. So observe carefully the blocks and we are going to continue with the activity. As you can see from the table shown on the screen, there are different combinations of the blocks. In the first column, you can see a combination of pink and blue blocks. In the second column, you can see a combination of green and pink blocks. And in the third column, you can see a combination of blue and yellow blocks. Can you try to observe these figures and complete the blanks in the sentences below? You will have to give the specific number of blocks required. As you can see, in this first combination of blue and pink blocks, you see that one blue block can combine with two pink blocks. Or we can say two pink blocks combine with one blue block. In the second combination of pink and green blocks, we observe that three pink blocks combine with one green block. In the third column, you can see that two blue blocks combine with one yellow block. In all these three different combinations, you can see that all hooks are paired. After having observed the different combinations of blocks in the previous slide, let us now try to answer this question. What factor decides the number of blocks which can combine together? Yes, you are right. The number of hooks present on each block. In fact, the number of hooks which a block uses to join to another block represents the combining power of the block. We have seen earlier that the pink block has one hook, the blue block has two hooks, the green block has three hooks. Thus, you can see that the blue block uses its two hooks to combine with two different pink blocks, as each pink block has only one hook. On the other hand, each green block combines with three pink blocks. This is because the green block has three hooks. So the green block uses its three hooks to combine with three different pink blocks. In the same way, each element has a combining power which determines the proportion in which the element combines with another element to form a compound. The combining power of the element is called the valency of the element. Table 9 shows the symbols and valencies of some elements. For example, aluminium has a valency of 3. Calcium has a valency of 2. You may also note that some elements like carbon has a valency of 2 or 4. Gold has a valency of 1 or 3. Table 9 continues on this slide. Here also you can see that some elements like iron and lead have more than one valencies. So students, what can we say about the valency of an element? Each element has a valency or combining power. This valency indicates the combining power of its atoms with the atoms of other elements. When the atoms of one element combine with the atoms of another element to form a compound, they do so in fixed numbers depending upon the valencies of the elements. Thus, we can say that the valency of an element is its combining power. Well, students, we have now reached the end of today's lesson. Let us summarize what you have learned. We have seen that some compounds exist as molecules. Molecules of compounds are formed when atoms of different nonmetals join together. Molecules of compounds consist of atoms of 2 or more types joined together, that is, atoms of different elements. The formula of a compound molecule gives the symbols of the elements present in the molecule as well as the number of atoms of each element in the form of subscripts. We have also learned that the valency of an element is its combining power. In fact, each element has a valency, a combining power, which indicates the combining capacity of its atoms with the atoms of other elements. Some elements exhibit only one valency. For example, sodium and potassium have a valency of 1. A few elements have more than one valencies. For example, copper can have valencies 1 or 2. Lead can have valencies 2 or 4. Thank you, students, for your attention. See you for the next science lesson.